Hi everyone, welcome to your notes for section 3.4, which is getting into linear inequalities into variables. So in today's lesson, we're going to be moving away from linear equations to linear inequalities. So if you guys remember back when we were doing inequalities, in chapter 2, right, we were doing our answers in interval notation. So instead of doing something like x is greater than 4, we were doing parentheses 4 to positive infinity. And instead of something like x is greater than or equal to 4, we were doing close bracket 4 to positive infinity. You guys remember doing that? Hopefully, possibly. So the same kind of rules apply when we're dealing with linear inequalities in two variables, but instead of being able to do an open parenthesis and a closed parenthesis or the square bracket, we use solid and dotted lines. So when we're going to graph linear inequalities, please jot this down in your notes, and again, pause it whenever you need to. Whenever we do not have the equals to sign associated with our inequality symbols, so just the less than and the greater than, then we're going to use a dotted line when we go and graph that line. If we do have the equals to associated with the less than or the greater than symbol, then we're going to create a solid line. So the dotted line, what that tells me is that all the points that fall on that line are not solutions of our inequality. And if it was solid, then that's telling me that all those points that do fall on the line are solutions to that inequality. Okay, so here is our first graph that we are going to do. I don't know, it's my head. Oh, there it is. Move myself around. Come back. Okay, so we have 3x plus 2y is greater than or equal to 6. And we need to graph that inequality. So what does that look like if we were just to graph that equation normally? So we've got all sorts of methods that we learned how to graph or remembered how to graph from the beginning of this chapter. So we can either set up a table of values, we could solve that for y and put it into y equals mx plus b form, or we could find x and y intercepts. Either works. I do see that I have 3, 2, and 6, which 6 is divisible by both 3 and 2, so maybe finding x and y intercepts would be the easiest here. If I wanted to find my y-intercept, I would cover up my x, which tells me that my y-intercept would be at 0, 3, because you would divide the 6 by 2. If I wanted to find my x-intercept, I would cover up the y, which gets me that my x-intercept, 6 divided by 3, is 2, 0. So we could do it that way, or we could physically solve it. If I wanted to do that, moving my 3x over would get us 2y is greater than or equal to negative 3x plus 6. Dividing everything by 2 gets us y is greater than or equal to negative 3/2 x plus 3. So either would work. If I do my y-intercepts, plotting 0, 3 and 2, 0, and then I could connect those. Or I could plot 3 and go down 1, 2, 3 over 2, and doesn't that get me to the other point there? Yeah, it does. So either way would work. That's up to you on how you want to get the graph. I do have an equals to at my inequality sign, so I'm going to make a solid line when I draw my line through those 2 points. And now we've got to decide where to shade. So when we were doing just one variable inequalities, we would either shade to the right or we would shade to the left, depending on which way that our equality sign was going, right? If I want it greater than, I would go to the right, less than would go to the left. So now we need to pick a tester point. And usually the smartest tester point to pick is the point 0, 0. If your line happens to go through 0, 0, then you can't use 0, 0, so you got to come up with a new tester point. But if I were to plug in 0 for x and 0 for y, what would happen to that left-hand side? 3 times 0 plus 2 times 0 would all just go to 0, and then we're left with the statement 0 is greater than or equal to 6. This is false. That's not true. 0 is not greater than or equal to 6. So that means the point 0, 0 is not a solution to this linear inequality, which means everything on the other side would be a solution to our linear inequality. So I'm going to shade everything above that line. So another way to think about this, when we solved it out and put it into y equals mx plus b format there, notice that I am left with that my y is greater than or equal to my line. So think about your y-axis. I'm going to get rid of this shading really quickly. Think about your y-axis. Here on your y-axis, going in the positive up direction, everything keeps getting bigger, 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 bigger. And going down, everything gets smaller, 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 smaller. So when we think about that line that we had, so we got 3 and 2, solid line, I want to think about, well, where on my graph does my y-axis get bigger? Well, my y-axis is getting bigger up here. It's getting smaller down here. So if you think about the purple line and either going above or below, which part of that line would get us to the higher y values? Well, going above would get us to all those higher y values, right? So if I use that thought process, that my y needs to be greater than or equal to, well, where do I get that y-axis getting bigger, 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 bigger? Above, as opposed to below it. Okay, so you can either use the tester point, or if you have that concept of greater would be above, less than would be below, then you can do that also. All right, let's do another one. X minus 3y is less than 4. Okay, so again, we could do y and x intercepts. If I wanted to do an x-intercept, it would be at 4. My y-intercept, this is in standard form, my y-intercept is not quite as nice, because notice my y-intercept is at negative 4/3. Negative 4/3 is about negative 1 1/3, so roughly like right about there. So it might be a smarter decision in this case to solve for y. So if I move that x over, I get negative 3y less than x plus 4. Dividing everything by negative 3. Now this is where mistakes are going to happen. Flip the sign when you divide by a negative. Gets me negative 1/3 x minus 4/3. Okay, so I still get that y-intercept of negative 4/3. And then going down 1 would put me here at negative 2 1/3. And then going over 3. Am I doing something wrong here? This doesn't quite make sense because that's not matching up with what I had there. Let me look. Oh, I see where my mistake is. Did anybody else notice my mistake? Right here. What happened when I moved my positive x to the right? Did it become a negative? Nope, it didn't. So that should be a negative, which would make that become a positive, which would make sense because now when I go up 1 over 3, it would put me here, and then up 1 over 3 would put me here. So we're getting, this is our line. Oh, and I already made another mistake. What should I have done? Made it dotted line, because we do not have the equals to. Okay, don't make this many mistakes, or make those mistakes, but then make sure you fix your mistakes. All right, so here's my line. Looking good. I'm going to dot it all the way across. There we go. So we've graphed the line. We made it dotted. Now we got to figure out where to shade. So I can either go back to that tester point. Because it's in standard form, that's pretty easy. I can plug in 0 for x and y, and I get 0 is less than 4, which is true. So that means I want to shade on the side where 0, 0 is, which happens to be above it. Or I can go over here, and I want my y to be greater. So where is my y getting greater? Above my dotted line. So all of my shading is going to happen above. So any point within that shaded solution, minus all the points that are on the dotted line, would be solutions to that given inequality. Okay, because all the points on the line would be exactly equal to 4. And we don't have that equals to there. So that's why they're not solutions. Okay, so hopefully we are good to go with graphing just a single linear variable, or linear equation in 2 variables. Now let's get into graphing the intersection of 2 inequalities. We're going to do the intersections, and we're going to do the unions. Now, if you guys remember, way back when we did intersections, those were your and compound inequalities. And most of the time, our and compound inequalities were, let me use dots, were something like this, where we had all the shading in between. We were looking for the intersections. Okay, so intersection, where are my inequalities intersecting is what we should be thinking about here. All right, so we have, my head there, we have to graph the inequality 2x plus 4y is greater than or equal to 5, and the inequality x is greater than or equal to 1. All right, so let's go ahead and graph. The first one's written in standard form, so we could find x and y intercepts if you want it, or if you want it to solve it out, would get us 4y is greater than or equal to negative 2x plus 5, dividing by 4, y is greater than or equal to negative 1/2 x plus 5/4. Okay, so 5/4 is 1 1/4, right out there. From there, I'm going to go down 1, which will put me here, over 2, would put me at that point. I'm going to do another down 1 over 2. We can go backwards and go up 1 over 2. Solid. I have to quickly check because we have the equals 2 sign. All right, so I'm not going to do any shading quite yet. Let's go ahead and get the other one graphed. X is greater than or equal to 1 is a vertical line at 1. I'm going to make it solid because it has an equals to. Okay, so now, back when I taught this, however long ago I taught Algebra 1, what I would have people do, now just watch this, don't put this in your notes, is I would have them get 2 different colored pencils, and then we would do 2 different colors of shading. So for the diagonal line, the 2x plus 4y, we had y needs to be greater than, so that would end up being above it. And then for the second one, we need x to be larger, so that would be to the right. So where are we getting larger? It would be over here to the right of the vertical line. And since we're doing the intersection, I'm looking to see where do the 2 colors intersect. Well, it's over there where you see both red and yellow. But we're going to advance our algebra. We're going to try to do that without actually having to do different colors. So does everybody see how you have area 1, area 2, area 3, area 4? Create it from the intersection of those 2 linear inequalities. So now what I'm going to think about is what areas would be shaded. So for our first inequality, which areas would be shaded? Well, area 1 and area 2 would both be shaded if I were shading above. And for our second inequality, which areas are to the right of that vertical line? Well, area 1 and area 4. Because I'm looking for the intersection of the 2 of them, what do they both have in common? Well, they have both area 1 in common. So my solution to the intersection is the whole shaded in of area 1. Okay, so that allows me to do it without having to do unnecessary shading. Because when I see your answers, I want just, bam, here is my shaded region that is the solution. So that means any point inside that shaded region would be a solution to both 2x plus 4y is greater than or equal to 5 and x is greater than or equal to 1. Okay, so now let's make it the union. If you guys remember back when we were doing the union graphs on number lines, we had something that looked like this, where we were doing the union of everything less than 1 and the union of everything larger than 2. So we would do negative infinity to 1, union 2 to infinity. So when we were talking about unions, we wanted everything brought together. So that same thing applies when it comes to unions of 2 variable inequalities. So again, we're going to redo the same graph just because we are used to graphing it. So remember, this went to y is greater than or equal to negative 1/2 x plus 5/4. So 5/4 is here, down 1 over 2, down 1 over 2, up 1 over 2, solid line. Didn't do a very good job, that's okay. And then x greater than 1 is here. So again, we get those 4 regions. So region 1, region 2, region 3, region 4. So our first inequality, if I were going above it, that would be regions 1 and 2. For our second inequality, if I'm going to the right, that's regions 1 and 4. Because I'm doing the union, I want to marry everything together, blend it together, a blended family here. I'm going to do all of those regions. So pretty much I'm shading everything but region 3 because I don't have a 3 anywhere in there. So my solution area is all of 4, all of 1, and all of 2. So I'm going to shade all of that. So everything but region 3 would be a solution. Okay? Alrighty. So before we end it, because that was the last one, I'm going to have you try one on your own, and you can be lazy about it if you want. That's fine. Lazy graphing's okay. So we have the inequality 4x plus y is less than or equal to 6. And x is less than -1. Take a moment to graph it, and then after you graph it, identify which point from the multiple choice options would be a solution or would be in your shaded solution set. Okay, so let's go ahead and do our graph and see how you did. So for the first one, hopefully you had your y-intercept at 6, 5, 6. And your x-intercept would be at 3/2, so 1.5. Hopefully you had a solid line. Your next one, you had a vertical line dotted going through here. All right, so we've got region 1. Region 2 is really tiny up there. Region 3 and region 4. So less than for the first would put us at region 3 and 4. Less than here would put me at 2 and 3. So if I'm doing an intersection, my solution is both in region 3 over here. And hopefully you picked the point -3, 0 for your answer. Okay, move on to your next assignment. It's been fun.